Hey, I'm Brian Costanza, and today I'm going to go through a tutorial on how to use Perlin Noise and recursive functions in your generative art. I don't feel like an artist so much, but I am familiar with the programming, with the coding, and that's what I'm going to help you with. So it may not look like a work of art after this, but now you're going to learn all of the tools you'll need to make whatever art you can imagine. And I will even show you some examples of that. Um, what we're going to do today is, well, like I mentioned, we're going to go through Perlin Noise, which is a very kind of natural kind of noise that you can use in your programs. And we're also going to use a basic recursive function because that can also be very useful in generative algorithms, generative art. And along the way, I'm going to show you a few other tools and tricks for how I like to organize my folders and my projects. Um, and then also show you well, how to save your art. We're gonna do something pretty simple. We're just gonna save some basic images when we run our code, but we're gonna kind of do that all at the beginning so that when we're done, we can go back and look at how our program, how our sketch has progressed over this hour or so um, of of instruction. Also, this tutorial is meant to kind of be at a pace where you can follow along as I go, and the finished product is also going to be available for you to download now before we started, which is the magic of the internet and YouTube. Let's first talk about just how to get our folders arranged. So we're going to come back to this a little bit, but I'm just going to go to my desktop real quick and show you what I've done. So if you go to my GitHub repository that I linked to in the notes, you can download the repo, and in there you're going to see this template.zip. And what this came from is there was a folder I already had on my computer that this was taken from. And I use that as a starting place for all of my new processing projects. Do a similar thing with Arduino. I mean, in reality, I use a few other shortcuts, but this is basically the equivalent without having to do some extra computer setup. And so what I would do is instead of template, I'm going to rename this to some kind of descriptive project name. So I don't know, we could call it a generative art test. We'll just call it generative art. Our project's called generative art. Okay, great. So that would be our top level folder. And then below that, you can see there's these two folders. One is build 00 and the other one is data. Now, build 00, that would just be the very first like version of the code that I'm going to write. So I would open up this build folder, and then I have a few things below it. So there's build 00, and then there's a folder just called build, and there's my sketch called build, and there's a data folder next to it. And what this kind of reflects is that the processing sketches that you run, they have to be named the same thing that the folder they're in is named. So if I have a sketch called build.pde, it has to be in a folder called build. And that's what you see here. May seem strange. Why are there multiple, you know, levels of build and all this kind of stuff? Well, it's because if you are working on this build sketch and you get to a point where you're done, or maybe you want to split off your work and work on it in a different way, but you want to preserve what you got to up until that point, what you can do is you can just duplicate this higher level folder, and then you don't have to rename everything below it for it to work. So I may start at build 00 and I do all this work, and then I say, oh, I want to split it. So I could just duplicate it, and now I have this copy. And then I realize, I want to call this something a little bit more descriptive than build 00. This is like my, I don't know, basic working version. That's not a great name, but you get the point. Then I can keep that there, and then I can work on this one. And then I might say this is my, working uh, plug-in version, or you can make up whatever you want, or actually to be similar to what we're going to do in this tutorial, you might say like this is sun, mountains, Lightning. Okay, so that would be a version that was working with those three things. But then I might keep going and say this one is add clouds and animation. Well, not animation. Add clouds and trees. There we go. So, so you can just kind of keep track of this stuff this way. And again, you don't have to rename all of these. So these are not great names, but I think you'll get the sense. And I'll show you what I'm using in my more live version. I also put a data folder up at the top, just inside of my project folder. And I don't have anything in there now, and I don't have any plans necessarily, but I do often use a folder like that for any files that are going to be used throughout all or most of my kind of like subversions, my subfolders of the project. And I'll save things in there. So things like images and fonts and things like that I don't need a copy for every single version, because I do have a data folder in here, but I usually use that for anything that's specific to only that build, or sometimes I'll save the outputs to that data folder. So that is that. And what I'm going to do is this one I'm just going to rename. I'll say this is actually the YouTube tutorial one, and I don't want that anymore. And what I'm also going to do is I have a folder going already. It's basically my repo, my GitHub repo for this project and related builds. And I'm actually just going to put it in there, because that just matches up with what I already have going. You're probably not going to take that step. So now for the rest of this project, I'm going to be working in this YouTube tutorial folder. And then we see the build PDE data. Okay, great. Let's jump in there. You'll see this Sublime Text icon. I really prefer using Sublime Text, but I know that a lot of people watching this tutorial are pretty much going to be starting fresh, and you might not be prepared to get in there and get Sublime Text or something similar to customize it the way you want. So I'm going to do this in the regular processing, the PDE processing development environment. So let's go ahead and jump in. What I've done in this template too is I pre-filled some of this information, and some of this is a little bit dated or a little bit irrelevant, so I'm going to take some of this out or to be filled in later, and yeah, something like that. We're just doing this tutorial. I'm not going to go ahead and bother with all of these things, but you may very well want to jump in and fill that in, or repurpose this kind of header information the way you want. But all of this, yeah, I pre-filled, because otherwise when you start processing, it's totally empty and you have to write all these things, which doesn't take a lot of time, but also you always need these functions anyway. So you might as well just set it up for yourself, and then hit the easy button. Actually, not even the easy button. You just take it easy. Do whatever you want with the extra time you gained. So, all right, cool. Well, here we are. We have this blank-ish sketch, ready to fill out sketch. And like I said, we're going to do Perlin Noise. We're going to do recursive functions, but we're also going to, look at the folder structure and organization, which we just finished. And the other thing that conceptually may seem last, but I really want to do next to save our progress as we go, is to set this up to save a screenshot of our sketch, of our canvas at least, every time we run it, or every time we do something to it, because basically it's just really fun to go back and see how the sketch progressed as things moved along. So that's what I have in mind. So let's do this. Right in here with the three kind of standard functions, we have void settings, void setup, void drop. Void settings is kind of optional, but I do like to set the canvas size in there, because then it lets me use the size of the canvas for any variables that I may need to do calculations on based on the canvas size during setup. So settings will run once, and then void setup will run after that just one time, and then void draw runs until you tell it to stop, or your computer shuts down, or you have an error, or something bad, I guess. But otherwise, settings, then setup, and then draw forever. Which curiously, we're not even going to use draw in this tutorial. So let's go to where we need to go to save these screenshots. So we're just going to go ahead and make a new function that will save a screenshot in the way that we want. So we'll do void, and we'll just call it make screenshot, I guess. Save screenshot. We'll call it save screenshot. And it's not going to take any parameters. We'll leave that blank. So just open parentheses, close parentheses, and now we have our empty function here. And as I think about this, what I would like to do is I want to save it in our project folder here. So our sketch is here under build, and then adjacent to it is the data folder. And I would really like to save it there. So we should make some strings that can specify that as the place to save it, which really we actually need to kind of go up to like up here and declare some variables. So most of these are going to be strings. So let's say we have string and then file prefix, and that's going to, actually let's just declare it here, and then we're going to modify it later. And then I do want to count the number of screenshots that we take basically on one start of the sketch. And so I'm going to need some kind of counter. Eventually we're going to convert that to a string too, but actually we want it to be an integer now because we're just going to count. And then when we make that final save, then we can convert it from the integer to the string. So I'm just going to declare an int, and then we'll do capture counter, something like that. That seems good to me. And then another string for file, not prefix, file suffix, which would be the ending, the file extension. We can save those later. So my ultimate goal, and I'll just write this in a comment here, is I would really like the captures to be saved in the data folder. So it'd be data slash, and then you might just prefix each file name with capture, and then it ends up making a really long file name, but it ends up being unique and a bit descriptive, and why not? We could do anything. Might as well make something that makes sense. And so what I do is I make just a long number string with the date and the time, so that ends up being unique. And then I'll just add another counter at the end of that. So it's going to be data slash, and then the file name would be capture, and then a code like 2019, and then it's November, so it's 2019 11 28, and then it is I know it's Thanksgiving, but it's grad school, and I got projects to work on, So here we are. So 2019, 11/28, and then it's 3:45, so 15:47, and 50 seconds. That would be my date time code. And then I would just probably put an underscore in there, and then I'll put my counter for the file capture there, and I'll save it as a PNG file. So ultimately that's what I want to save. So now I'm kind of working backwards to figure out a way to create that. So we have a file prefix, which can capture all of this. Capture counter is this number here, and the file suffix would be the .png. So I could mess with some things up here, but I really like to just, if I need these variables available everywhere, like these are going to be global variables, I declare them at the very beginning of my sketch. And so everything kind of like below that will still have visibility into it, or we'll still be able to see it. And so that's why I'm declaring it up at the top level. So here at setup, let's go ahead and build this up. File prefix, that we're going to do that soon. That can be a little bit complicated. Capture counter, that yeah, we can go ahead and set that to 0, because when it first starts running the program, it's going to be 0. So we'll do that, and then the file suffix, that is going to be really easy. It's just .png. There we go. So we have those two things set, but now the file prefix, that it's going to take us a moment to kind of set up, because we have all these dates, and then the way that the conversion from integers, like the day number, the minute number, things like that, the way those convert automatically from integer to string, it's not going to pad any zeros, and I want my strings to be the same length every time. So if it's hour 1 or 13 or something like that, well, 13 would be fine. If it's month 6, I don't want 6, I want 06. So we can do some formatting with that. So let's go ahead and start putting this in. So we wanted to start with data / capture. So it's the data folder, and then capture at the beginning of our file name. And then we need to make our code. And it's really convenient in here when we add strings, they just concatenate together, they stick together, and that's what we're going to utilize here. So we have the data / capture, and then we want to start adding the date code. And since this one ended up being kind of long, I want to break it across a few lines. So I'll just hit enter and put this in, because processing will read until it sees a semicolon, and then it's going to say, okay, that should be read as one line. It gets interpreted as one line. So just add the plus, and now here we go. So we're going to do year. That's a function that returns the year, and that's going to be 4 digits for the next 8,000 or so years. So I feel fine using 4 numbers for that. And next we have a month. So that's good. And let's pause here, actually, because we know month is not going to work out the way we want for most of those months. We need to format this, and I almost always keep the processing reference up when I'm coding, because like I know the general principles, but the exact details are really easy to lose track of, so I like to keep it around. And I remember that it's something called NF, so not info, here we go, NF. And so there's a group of string functions, and this NF I know is the one we're going to want. And I won't read through this here, but I can just tell you that basically you pass in a number, and then you tell it how many digits you want, and then it formats it as a string that way. So it's a really good way to do the 0 padding for numbers. So we're going to do NF of month as the first parameter, and then I'm going to put the number 2, because I want to make sure it always has 2 digits no matter what, and that's it. That's what that function is doing there. Okay, we got the month formatted the way we want, and I don't want to retype that month thing every time, and I'm going to need a new line every time, so I'll copy all of this. So that's going to be month in place, day, and then hour, minute, second. That should do it. So month, day, come on, hour, minute, second. All right, and I'm not going to add anything after that. Semicolon. Great. So this is all getting read as one thing. Ooh, file prefix. There we go. That cleans that up. So the file prefix, the counter, the suffix, and there we go. Now we can go ahead and create this. Now there's a function called save, and you can call it at any time, actually, while you're drawing these functions or drawing these sketches, which I think is really interesting. You can kind of call it before it's done and see the intermediate steps, though we don't exactly want to do that. But anyway, there's this function called save, and all you have to do is pass it a string of the file name you want. So we're going to go ahead and build this string right in here. It's going to be the file prefix, which has our folder and our file name. Well, the beginning, well, the code, at least the capture and the date code, date time code. So file prefix plus an underscore, which I could have added that before, but this is how it's kind of turning out. Then we want the capture count, and that's going to be an integer, so we're going to use nf again, capture count. And we want, I'm going to do 4 because I don't think we're going to do more than 10,000 screenshots. 1,000's probably fine, but hey, it's basically free, so let's do it. And then, what's wrong here? Capture count does not exist. Capture counter. It's capture counter. There, now it's happier. And then file suffix. No red. So I think we're good. That could be good. All right, so I'm going to go ahead and, well, I'll leave that comment. I mean, it's kind of descriptive and helpful. So that looks good to me. Let's see. Now we will go ahead and, even though our canvas is blank, I mean, we do want to make sure that it works, and we kind of want to capture every step of this getting built up. So, oh, not in draw, because we're going to take a ton of captures if we do that. Let's just put it in setup, so it'll just take one screenshot as we go. So here we go, and hit run. How are we? Okay, that's blank. That's fine. We kind of expected that. And look, there we go. I think this is what, yeah, blank. 2019, 14:56 minutes, 14 seconds. Yep. And capture count 0. So good. So that's that seems to be working as we wanted. Now, all this, may have mentioned this before, but this file prefix part, I really want this code part to be the same every time I run the sketch. So it's really only this counter part that advances every time. It gives me a little bit of kind of like traceability of like when I did that thing or what each iteration did. So then I can kind of compare visually how one version was working from another one. Just something to keep in mind. So all right, well, that was cool. That seems easy, and now we're going to be capturing things along the way. We'll end up moving this around a little bit, but at least that functionality exists. Let's get started with our Perlin Noise. So, like I said before, the Perlin Noise is it's meant to be random, but not like total noise. It's meant to be kind of like a natural looking noise, so that you can make natural looking things. And we're gonna utilize that to make mountains to start with. So where to begin? I can tell you already that the function is called noise. Very descriptive. And that's what we're gonna do. So again, since we're not drawing this over and over again, I feel comfortable just putting this in the setup function for now. But because we're kind of doing this live in a way, I'm developing this code or this sketch in a way that that you would expect a sketch to kind of unfold naturally and develop naturally. Like you put things where they need to be to make it work, and the further ahead you can see, the better. But it's not exactly necessary either. You can just sort of do what you need to do at that moment, and then fix it and make it better as you go. And we're going to kind of take that route. So what we're going to do with this noise function is, yeah, you basically every time you run the function, or every time you run the sketch, you get what I just think of as like a volume, a 3-dimensional volume of random noise values that are based off of Perlin Noise, and then you can kind of travel through that space in any direction you want. You can have a point kind of traveling through that space, or you can kind of like, this is figurative, but drag like a line through that space, or you can sample through a whole plane and move that or not move it if you care to. And so what we're going to do is we're basically going to take one like a string of data out of that Perlin Noise cube in here and use that to make our mountain range. Okay, so let's do that. What we need to do is we're going to need to do a for loop, because the mountain range goes from edge to edge of our canvas, and we need to take a sample basically for every pixel that we have on the screen. And so we're going to do a for loop that starts on the left and moves all the way across the right. So one loop for every pixel of width that we have. So for int equals 0, so it's going to start at 0. Oops, I mean for int I equals 0. There we go. So we're declaring the temporary variable I. We're going to start at 0, and then for as long as I is less than the width of our sketch, then we want to increment I and run the loop again. So that's the for loop. And now let's go ahead and sample this noise. And you know what we could even do? We could print this to the console to kind of see what kind of values we're getting, and then figure out what kind of math we want to do with it. So we'll do noise, and then noise can take 1, 2, or 3 parameters for X, Y, and Z. And we're just going to go ahead and pass it one value. We're going to pass it the X. Well, it's Y, which is actually the X location pixel. So noise of I, that's it. Oh, well, we want to print it. So print line noise. There we go. So that'll run once through every pixel. I use my keyboard shortcuts a lot, so Command R will run your sketch, and look at these numbers. So we're getting values less than 1. So it looks like it returns values between 0 and 1 based on the Perlin noise, and that's good to know. So if we just graph that as it was, it would all pretty much look like 1, maybe 2 pixels different, and we don't want that. So we'll need to make it a little bit bigger. So if we say like do noise times 100 and run that, now we're going to get numbers, yeah, see numbers 70, 39, 21. So those are definitely values that we would be able to see on our screen if we did that. So that seems like a good start to me. And now that we have those numbers, we don't need to print this anymore. We want to see that on the screen. So the next closest thing that we could graph is point. So we do point. And then that same noise value. And let's see here. Oh yeah, so point needs 2. It needs an X and it needs a Y. And the X value is going to be held in our I variable. So point XY would be point I, and then the noise value times 100. Let's see that. So okay, cool, we're seeing something there. Doesn't look like mountains though. It looks super random, and that's not going to be good for us. And well, I just tell you what's happening here. Basically, Perlin noise, at least in my eyes, it varies over a very small scale. So if you take steps of 1, it's going to look completely uncorrelated. But if you take steps of fractions of 1, of like if you take steps of like tenths or hundredths, it's going to be much more closer together. So instead of taking steps of 1 here with this I, let's go ahead and multiply this by some small number. Like what if we do say like 3/10? If we do that, no, it still doesn't look too good. I can tell it's getting better, but it's still not quite there. So 0.1, oh, there we go. That's looking correlated. Now we're talking about some good noise. So that's with 0.1. You can see if you did 0.01, yeah, it's really smooth there. And I mean, you can keep going. 0.001, I mean, it's not a straight line, but it's really smooth, quite flat. So you can use that however you choose. So I think 0.01 is probably closer to what we want for our mountains. I'm even gonna make it a little bit rougher than that. 0.05. Yeah, I like that for now. Let's stick with that. But now there are some other issues, like these are dots, and we want nice lines, like a contour for our mountains. So let's go ahead and set that up. What we're going to do is we're going to create a custom shape here, actually. So just like there are circles and rectangles and triangles and lines and points in processing, you can make your own if you need to, and we do need to, so that we can control how it looks. completely. And we do that with begin shape and end shape. So begin shape, should be capitalized S there. Okay, that's good. So we're going to say, okay, hey processing, we're going to start a shape, and I'm going to tell you what all of the vertices are. So begin shape, and then instead of calling point now, we're going to say vertex, and then end shape over here to say, all right, I'm going to start a shape, and then add a vertex to my shape and all those places that you were making points before in the for loop, and then end the shape. And there's going to be an issue with this, but I really want to see what it's like. Okay, cool. So I like that line a bit, but obviously that, well, I like the contour line, but the line cutting from the very beginning to the very end is not how I imagine the mountains looking. So what we should do is, I think we're going to both get rid of this contour line and make sure that this completion line doesn't run all the way through. So let's go ahead and add a couple vertices to round it out. Basically, if we just add a vertex at the bottom left corner and add a vertex at the bottom right corner in the right order, then it will complete this shape, and then we can fill it and add lines or remove lines just like all the other fundamental shapes that you find in processing. So let's go here, and I think for me it makes sense to start off with adding a point at the bottom left corner. Then we could run this contour, make a point at the bottom right corner, and then be done. So let's see here. So right after begin shape, we're going to add a vertex manually here, not in the for loop, and say the x value at the bottom left is 0, and the y value is equal to the height. So we've added that bottom left vertex. Then we go ahead and add all of the mountaintop vertices. And then when it's all over, we're going to add another vertex manually, which is going to be at an x location of width and a y location of height. And yeah, and there you go. But also, we don't want to have that line, well, the outline, basically. You could do that for your effect, but we're going to take that off here. You'd end up with a little bit of an issue with the outlines on the edges, and there's some other ways that we can handle that, but I think that's a topic for another video. So let's go ahead and, right before begin shape, let's go ahead and do no stroke. So that will take the outline away completely. And I want to fill the mountain shape with some color, and I don't know, I mean, I'm fine with grayscale for now, and let's go ahead and, oh, you know what, now let's use the color tool here. So we can go to tools, color selector, not the fanciest color selector, but you know, it's all right. Yeah, mountains might have, again, I'm not the artist here, but we're just going to pick something so we can get some colors. All right, why don't we call it this kind of purplish color? Copy this code, and we're going to put that in for the fill, and there's our mountain color. So let's run this. Oh, okay, it's something. Now, something else I find a little bit distracting, these mountains are really high. It doesn't give us much sky to play with. I want to move these down, and then after that, we'll even make another mountain range a little bit lower down. So we want to take care of all that, or start taking care of that. So let's give it an offset. So since the coordinates start at 0 at the top for the y value, we want to add some distance to put it in the right place. So here we have the vertex and the x and the y. So we want to add to this y value here. And I don't know, for now, let's say we want to add it. Well, you know, I hope I don't need this color selector anymore. If we just add from the top, that still kind of leaves things a little bit loosey-goosey, I want to say. Why don't we go from the very bottom and then add an amount, or subtract an amount to make it. Okay, so let's go ahead and instead of adding here, let's go over here. We're going to start with the height, and then we're going to subtract the noise, and also another constant. So I might call it, or not width, height over 2. So we'll just kind of say, go to the bottom, add half the height of the screen, and then add the noise on top of that. So our mountains should show up just above halfway. Looks like we might have a parenthesis imbalance. Yes, so there we go. Okay, yeah, it looks about right. The mountains are just above half, and I like that look. So let's run with that. Now, I do want to make this code a little bit more reusable. So let's take the code that we use to make those mountains and make a new function out of it. And then we're going to add some parameters to let us customize the mountains every time. So let's not move that yet. Go down here, do void, make mountains. That looks good. And now I'll grab what we had done with our mountains and take it out of there. Okay, that looks good. And although we took it out, now we need to call our function make mountains here, or we won't get any mountains. That code will never get called, and that's no fun. So let's just run it and make sure that's all lined up. Okay, looks good. What shall we do next? So I think that it'd be nice to set this function up to have different mountain ranges. And so I think we want to be able to set the texture a little bit, not better, but to set it when we call the function. And we also want to have the height of the mountain set from calling the function too. So let's go ahead and call that, or even, I think we should even add the color to that as well. And then we can change the height, the texture, and the color all with the same function call. So let's go ahead and add that to this mountains function here, and then we'll go figure out what that looks like. So first we'll do offset from top, offset from the top. Yeah, see, you heard what I had done before. I've thought this through a couple times, so we're not sitting around. But anyway, we're going to declare an integer, and we're going to do offset from top. Yeah, that sounds good. And then we're going to need another parameter, which we said would be the texture. So even though we called it the texture, and it is, it's probably going to be better to call it something else in the code because of the way that this Perlin Noise stuff is calculated. So let's just call it something like noise scale. Noise scale. That seems good. So integer noise scale, no, it's not an integer, it's a float, because it's going to be a pretty small number, a decimal number, and we need a color, so we'll just call it, I don't know, the color. Okay, offset from top, noise scale, the color, and one other thing, I think not only do we want to be able to change the texture, kind of like the roughness of the mountains, but I think we should also have something to determine like how much magnification we give to the noise. So let's do another float here called, I don't know, scale factor. Okay, offset from top, noise scale, scale factor, and the color. That sounds good. And now that we have this, let's start putting things back into the original function here. So offset from top, that should go right here. This was our offset from top. So paste offset from top in there. And here we do height over 2. That was the same offset from top we were using before. And actually, it's not offset from top anymore because we're doing it from the bottom. We're doing offset from bottom. Yeah, I know that that math gets a little bit complicated, but again, I'm really thinking of this is sort of like I'm thinking of the higher you go, the greater the value. So that's kind of what we're dealing with. So we changed the math that way. So okay, offset from bottom, and then the noise scale, we're using 0.05. So we'll take noise scale, put it in there, and then put in 0.05 there. And then the scale factor, we're using 100 right now. So let's replace the scale factor there, and we'll put 100 there, not 199, 100. And then the color, let's replace that. Well, I want to save this first. So pull out this color, and we're going to put that there and replace it with the function. Great. So now we've made this really universal. Now it's not going to look any different yet, except for the randomness being different, but this shows us it looks like the function is working the way we intended it to. So great. Let's go with that. And I would now like to have actually a different mountain range that's a little bit lower. So let's call this make mountains function again down here. And we'll change the color a little bit. Go back to the color selector. And, who knows really, but why not this color? We'll go back here, paste it in. And we want it to be, we'll just do like height over 4. Noise scale, I want it to be smoother, so I'll put in 0.01. I don't want them to vary by as much height, so I'm going to put in 50 pixels there. And okay, cool. Not a whole lot of contrast, but it looks fine. Should we bump it up a little bit? Let's bump the contrast up a little bit. Should we do a really dark? Or really light? Here we go. Okay, I like this. Instead of having to run the sketch every time, we can just click the canvas, and then we'd get a new image and it would save automatically. That seems like a great next step to me. So let's go back here. There is a function called mouse clicked. It's amazing. Already exists. And every time the mouse gets clicked, it'll run this function and run whatever code is in there. So let's go ahead and do this thing where in the setup, make mountains. Okay, we actually need to do this in 2 steps, because every time we click the mouse, we want it to make a new scene. And we don't really have the new scene creation taken care of in one place. It's taken care of in a couple places. So we just know we're gonna make a function. So let's call it make new scene. We're gonna make that a new function, but we'll call it there. And then right below it, we'll declare this make new scene. Good. All right. So we have that. And then everything that goes into making a new scene will move into there in... well, not actually in just a second. We're going to do it right now. So right now what we have done is every time we make a scene, we make these 2 mountain ranges. And so we don't want to call those specifically there. We want to call it make new scene. But now on the setup loop, right now we won't have anything at all. So we do still want to make a new scene as soon as everything starts up in the setup loop. And we do want to save the file here, but actually we really want to save the file or to save the canvas every time that we do make a new scene. So we're going to move that to the make new scene function as well. And let's clean this up a little bit. And this looks great. So on setup, we'll run the make new scene, and also every time that we click the mouse, we are going to make a new scene, which now involves making 2 mountain ranges and saving the image. So let's go ahead and run this, check it out, move this over. Yep, look, we've got things have been saving, so that's good. And that looks like what we have right there. And if I scroll through these, yeah, that looks like the work we've done. This is great. Okay, so I feel good about that. let's leave that Finder window for now. And let's think about what else we want to do here. We know that, well, there's no sky yet. We could set a background. That's easy. And then we can make a sun after that. Let's do that. So when we make a new scene, we want to set a background. Always miss that G. Background. And let's find a color for that. So tools, color selector. I mean, the sky is blue. Our mountains were a little bit blue too. Maybe it's more of like a sunset-y color. Like it's getting late and it's getting nice and moody out there. Maybe something like this. I think it should be a little bit more orange. Here we go. I don't know. Let's see how this goes. And then we'll put that color in there and run that. Oh, we missed something. We missed the 2 on the end. Ooh, okay. Well, it's a little bit wild, but let's just go with it for now, you know? Why not? That's the background color. Yeah, I should get a color expert in here to tell me what I'm doing wrong. I know it's not right, but what is? Oh well, at least that's easy to fix, right? We want to make a sun as this goes along. So let's do that too. And it would the sun would be behind the mountain, so we need to paint it or draw it before the mountains. So let's just go ahead and make a function called makeSun because we want to put all that code in one place. Here we go. Okay, and then void makeSun. Oops. Okay, cool. And as you may know, the sun is round. You know what though? I've left one thing behind. Let's come back to the sun in a second. We've made this scene, and when I click it, it is going to create a new, well, maybe not. Let's see, make new scene, save file. It's overwriting, I bet it's overwriting the file right there because we are not incrementing our counter. So every time it makes a new scene, we want to increment the counter. So file or capture counter, right? Yep, capture counter. There we go. So now when we click it, we're going to get a new one, but see, these are both from the same time, and we're getting a new capture, but the mountains are not changing. And the reason for that is that the what's called the noise seed for the Perlin Noise, it gets generated when you start the sketch, and then it stays the same for that whole sketch, so that you know that you're always kind of pulling from the same like noise space, and that's great when you want it consistent, but we actually want this to change every time. And so what we can do is we can actually change the noise seed manually with a function called noise seed. So I would say that we want to use a different set of noise every time that we make the mountains. So in this make mountains function, we want to pick a noise seed, and we can just go ahead and do that first. So noise seed, what it does is it takes an integer that then gets used to generate this noise. And so what's also interesting is that even though if you use Perlin Noise normally, it would be different every time you run the code, every time you start the sketch. But if you use the same noise seed every time, you can have the same noise. So if you don't want it to be different, just make sure you're using the same noise seed, set and use the same noise seed, and it'll be the same. But we want it different. So I'm going to go ahead and just do I'll just say, hey, I want a random number from 0 to 10,000 and use that as the noise seed. But I'm getting an error here because noise seed wants an integer and random generates a float. And what you could do is you can convert it with this int function like this. And that totally works. That's common. I kind of prefer the look of the typecasting. So typecasting is just putting a data type is surrounded by parentheses before a data type, before like a variable, and it will coerce that type into the other. So in this case, this float that is created by random will be coerced into an integer, or be converted into an integer, and there you go. So that's how I'm going to do it, and that's how I'm going to make sure that the mountains get different noise every time. Now let's run it. Oh, look at that. Totally different mountains every time I click it. And now we're going to have a collection of mountains there. Okay, looks good. Now let's go back to our sun part. Again, I'm feeling silly about these colors, but the important part is that you're learning Perlin noise use and recursive functions next. So, but anyway, we want to make a sun. So, making this sun, we know it's an ellipse. I mean, it's a circle, but we'll use the ellipse function, and then we give it an x, a y, and then the diameter across the two axes. So, we could do. We want to use some random numbers here. So let's do random. So anywhere between the left side of the screen and the right side of the screen would be fine. So the x can be random width. So that will be random between 0 and width. And then the height, we want that to, or not the height, but the y location, we want it to be like at least the top half of the screen, I think. So we could do random to height over 2. There we go. And it's still going to use the colors from before. Oops, we need the diameters too. For now, let's just do 100 and 100 for the width and height of the ellipse. And then we need a fill. Let's go back up to this color picker. Something like this. I might regret this too. But now we're going to set the fill, and we also know that we don't want any outline around the sun, so let's just go ahead and do no stroke here as well. We've set that before, but things could change on the rest of our sketch, and we never want the line around the sun, or we can come back and say we actually do want the line around the sun. So no stroke, fill with a yellow color, draw this ellipse, and that should be good. So let's run that. All right, so we've got our sun showing up there. That's cool. I would like to add a little bit of flair to this sun, though. And it's interesting. I see a gap of orange there on the side of our mountain. So I have a little numerical issue with that. Can look into that in a second. But let's work on our sun a little bit. We want to. Or I want to add a little bit of like a pattern to the sun. Give it a couple of layers, so there's like some texture, some interesting stuff to look at on our sun. So I'm going to do a couple of rings. So I copied this ellipse function, but I already know that I'm going to have a few issues. You can see that the x and y locations are picked randomly each time, so our sun would jump around. I mean, I'm going to show you that. Not exactly what we want. Oh, that's an interesting situation, but it's not exactly the look we're looking for. So let's change this up. I think I'll go ahead and fix the diameter, the x location, and the y location all at once. So let's go ahead and pick a base diameter. So we'll declare this variable int diameter. And why don't we pick a random number between, I don't know, 80 and 100 pixels Those are 100 now. That seems about right. So maybe we'll do 70 to 100 to give it a little bit more variation. And again, random delivers a float, so let's change that to int there. And then the x location and y location, so I'll just do xloc int xloc equals random. And I'm fine with these the same range of values, so I'll pull that from there. And I'll do int yloc, and I'll pull that from our calculation before. And now again, we've got the type mismatch, so I'll do int as the typecasting there. And now I'll say x location, y location, and then diameter again, and we'll copy that. Looks good. And I want the sun to fade a little bit, and I want the outer rings to be a little bit more transparent. So we're going to do some cool stuff with the fill. Let's make a new variable color. Let's see, sun color. We'll call it sun yellow. Sun yellow. And that's going to be equal to this number that we pulled before. And now I'll take that away there, and then we're going to do a fill before each one. But we want to use sun yellow here. There we go. And now if we just do fill sun yellow, it will be completely opaque and use that color, but we want the outside ones to be a little bit more transparent. So why don't we do a 25, and then we're going to do a 50, and then if I remember correctly, 100 is completely opaque. So we have 3 rings. It's going to be very opaque, moderately opaque, completely opaque, and I also want the more transparent rings to be a little bit bigger. So we need to do that, and I'll go ahead and make it like 40% larger, so multiply it by 1.4, and same here, times 1.4, then probably do 20% larger on the others. Let's see, times 1.2, 1.2, let's see what happens. Yeah, hey, that's not so bad. Not so bad at all. Okay, pretty satisfying. But we still haven't done the recursive function yet, and this is just a little bit too peaceful of an image. So we're going to add some lightning to give it some danger and some excitement. Let's do it. All right, so we're going to simplify our lightning a little bit. We're going to say that, at least to start with, it'll probably just be 1 bolt. It's going to start at the top of the screen, and we'll build that. And then we'll make some modifications to make it look a little bit better. But I'm sure the sky's the limit on how to make the lightning the most realistic thing ever. And if you stay tuned to the end, I'll even show you how else you could use the recursive algorithm, recursive functions to make some cool stuff. I'll show you another example that I did not make, but it's based off of what I did here at another workshop. So to stick with the conventions we've been using, we'll just go ahead and do a make lightning function. And we're definitely going to pass it some parameters, but let's deal with that later. And also, let's just go. No, we won't make that function called yet. Let's see. So our lightning, it's going to be pretty bright. So I mean, I think we should saturate it with white. So let's go ahead and we're going to call no stroke because not no stroke, no fill, no fill. But we're going to have a stroke that will just make full white. 1, 2, 3, 4, 5, 6. That looks good. And it's going to be a line to start with. So Let's say now that it is going to, let's just take like an X location and a Y location, similar to what we did with the sun. So the X location, actually, I'm fine with it being, well, no, it's going to be similar to the sun, but not quite the same, because the lightning, we don't want it to start at the edge of the screen and then go off the screen. So let's go ahead and make sure we pick something that is a little bit better. So we're still going to do this int of random, but the leftmost extreme, we're going to set it at like 10% of the width, so like 10% in from the left side. So random width times 0.1. That'll be the lower bound, and then the upper bound will be width. Yeah, we could do 0.1, but let's just do divide by 10. It's a little cleaner. Width times 9 divided by 10. So that will keep it 10% away, 10% of the width from the right side as well. And yeah, that looks good to me. And X location not declared. So int X location. And then int Y location. Actually, we can set it at 0 because our lightning is going to start at the top of the screen and then go from there. So Y location 0, and then let's see here. So we want to find out where a good next X and next Y would be. And well, actually, maybe just call them X next, X or Y next. Yeah, X next, Y next. Tongue twister. We got a new tongue twister on our hands. And we'll have to go back and rearrange this, but I know that we'll have to do this. So let's just go ahead and figure it out now. So int of X next equals, it's going to be based on the previous X location and then diverge from that a little bit. So let's go ahead and say that it's the X location plus a random number between, I would say, the lightning could probably travel left or right. I don't know. Again, like a tenth of the screen, perhaps. So we'll just do width over 10, but negative width over 10 as the lower bound and positive width over 10 as the upper bound. Yeah, it'll start at the previous X location and then jog anywhere between a tenth of the screen left to a tenth of the screen right. And oh, we're getting our type mismatch again. So we'll typecast that. And another int Y next equals Y location plus integer random. And this, I would say, it could be a minimum jump of nothing. Maybe even it could go backwards a little bit. Let's make it possibly go a little backwards, just a little bit. Negative width over 20 to width over 10. Sure, sounds good. Well, that means a third of the time it would go backwards. I don't like that. Let's just have it travel down only. There we go. Between 0 and width over 10, it'll jump down. Okay. Now, yeah, so now I'm starting to see where we've worked ourselves into a corner a little bit, because we're going to make this recursive function, and it doesn't know where it's going to start each time, even though we've hard-coded this start place here. So actually, the start place needs to come in from where the function is called, and then we'll do some calculations from there. So why don't we actually move these up here? So int xloc, int yloc, and then we'll pull those locations in from elsewhere. And then when we call this lightning function from our make a new scene, it's going to, so sun, mountains, lightning. And we're going to use what we figured out here. We're going to use up here instead. There we go. And make lightning, it's going to start at 0. And we're going to get rid of these. That looks good. And then we need to draw a line from the x location to the y location, or not, sorry, from the x location, y location coordinate to the next one. So x next, y next. Boom, there's a line. Let's go and just see if a line shows up. Okay, great, we got a line right up there. Pretty skinny line though, so we'll need to do something about that. We can increase the stroke weight to make the line a lot thicker. And, you know, lightning, in my mind at least, it gets thinner as it travels down. So we're going to want to do that. And so that'll be recursive as well, part of the recursive like properties. And so let's go ahead and we're going to make a float be the weight, the stroke weight really, but we'll just call it the weight. And then we could say stroke weight of the weight. And then when we call the function up here, where did our lightning go? Here we go, make lightning 0. And then I think we'll just start with a stroke weight of 10 at the top, and then it'll get thinner and thinner as it goes down. Then, yeah, so let's just see that thicker line show up. Okay, that's good. Yep. And then now we're going to make it recursive. We're so close. We got everything pretty much lined up, and now we need to make it recursive. So what we're going to say is that if the end of the lightning bolt, or the portion of the lightning bolt that we've just drawn, if it's not below the bottom of the screen, then call the function again and make a new lightning bolt link, I guess. So say if the next, so the y next location, if it's less than the height, keep mixing those e's and i's up, then call it again. So it's less because, again, it's 0 at the top, and then we have the height value at the bottom. So if the y location is not increased to the point where it's past the bottom, then keep going. So then we'll do make lightning again. So we'll just copy our example from up here. Make lightning. So if we're not off the bottom, call make lightning, and that should be based off of the, let's see here. So we have the x and the y and the x location, y location, and the weight. Did I have an extra one up here? Oh no, that was the y. That's good. Okay. And the weight. So the weight actually, we're even going to call this next weight, because right up here we'll take next weight float. Next weight equals the weight times some random number between, let's say, I kind of got a sense for this earlier, between 0.7 and 0.95. So it will go down a little bit in the weight of the line each time, but that'll vary. Okay, so next weight equals the weight. Yep, that looks good. And I've got an extra one here. And then the x location, so we should say that y next, so x next will be the x location of the next round. So we're going to pass it the x next and the y next. And then all the jitter gets handled on the next iteration. We tell it what the next weight should be. And there we go. Let's see how this goes. Oh, yes. Nice. Let's see that lightning. Oh, yeah, all kinds of lightning here. it seemed for a second it was hanging out there in the middle, but it does seem to be jogging around like it's supposed to. So I'm satisfied with that. However, one thing I'm not satisfied with is I really feel like it should be branching out more as it goes. And but again, randomly. So let's add some randomness here to give it a potential to call the make lightning function again. And so what we're going to do that is basically kind of like roll the dice. We'll use a random number generator again, and then if the number that's generated is below a threshold or above, it doesn't matter, then call the make lightning function again with the same ending value from the previous part of the bolt. So we're going to do another if statement here. So if let's roll the dice, kind of the infinite dice because it's a floating point, a number between 0 and 10, and say if it's less than 1, so about 10% of the time, it will branch out as if I write it like this, and it would be the same function call as above, but the output of these different make lightning calls will be different, so we'll get two different waves. So let's see how this goes. All right, nice. Yeah, that seems about right. Wow, that's really crazy when it starts so early. Okay, pretty satisfied with that. Okay, I think that I think we'll call that pretty good. You have now seen how to use Perlin Noise, use recursive functions, and set up this basic scene, and you're ready to rock. I do want to show you a couple other things that I have though. Well, I need to go up one. To show you what I've done in the past, I did this in a classroom one time, and I ended up with, well, you can see that. This is what it looks like when I'm running it in Sublime Text, and there we go. Similar thing, similar lightning, similar mountains. So, kind of followed the same process as what we did in this video, and I made the regular processing very unhappy by doing that. And then this one's a little bit silly. This is some preparation I did a couple months ago, and I had added some trees to be drawn, just some very rough trees, and I put that tree function inside of the mountain drawing function so that it would randomly pick an area in here and then make sure that it was drawing a tree that was on land, basically, and make sure that it didn't end up up in the sky there. You can see the algorithm that I used for the lightning made a slightly different pattern there. So you can go ahead and look at that in the example file in my repository and see what you might like from there, and take it for yourself. And then there's one thing that I really like. One of my friends from that workshop that I just showed you was she was very inspired by the cherry blossoms in Japan, and she made this. She just took the code that I had basically, and you can see this tree looks a lot like that lightning, but it's turned the other way. Changed the colors, made a nice little sky background, and instead of drawing yellow suns, they're pink cherry blossoms, and I find this very pleasant. And this is where the artists come in, and where I go out, I suppose. But there you go, a little bit of inspiration, a few other examples, and we're gonna call it good. Thanks for following along. I hope you enjoyed it. I hope you learned. I hope that it was informative about some of these really important generative art, generative algorithm concepts, and let me know what you make. Thanks a lot. Talk to you later. Bye.